Today we're going to look at properties from algebra, and this is the last day that we're going to work on this topic. The first proof we're going to look at says RS is equal to PS and ST is equal to SQ, and we're trying to prove that RT is equal to PQ. So the first step is going to be our given, and once we have it written in our proof, we're going to mark our diagram. So RS is equal to PS, and then I have ST is equal to SQ. Now, in looking at our second step, it says RS plus ST is equal to PS plus SQ. Now, this is where a lot of students are just struggling with initially since proofs are new. We're trying to decide, is it addition or is it segment addition? Now, remember, segment addition postulate is when you have two small pieces equal the big piece, which in number 2 is not what we have. In number 2, we have RS plus ST, and then we have equals PS plus SQ. So where did they come from? If you look at the step above, RS plus ST is right there. We have two equations, and what we did is we chose to add them, two parts of the equations, together. If I look at the other part of those equations in step 1, PS and SQ, I added those together, so I combined those. So the reason for number 2 is addition, property of equality, because I had two previous statements that were equal, and I added parts of them to form another equality statement. Now, moving on to step number 3, I have RS plus ST is equal to RT, and I have PS plus SQ is equal to PQ. Well, this is one of those where there's two statements there. There's one here and one here. The reason they are under the same number in the proof is because the reason is the same. And the reason in this one is segment addition postulate, because each statement says a small piece plus another small piece equals the big piece. So that's segment addition postulate. Now, looking at our last statement and trying to prove that RT is equal to PQ, what I did was I kind of moved things around. So, and in looking at step number 3 and step number 2, so I'm concentrating on 2 and 3. First, I have RS and ST, that's red, and that's what I have right here. That's the same as RT. Kind of move that on top of there. And I'm looking at the other part of that statement. I have PS plus SQ is in blue, so I have PS and SQs here, and again, that's the same as PQ. So that's the same as PQ. So basically what I did in step 2 and 3 is I replace things or I move things around depending on how you want to say it. And when I do that, it's substitution. So it's substitution property of equality. In our next proof, we have the measure of angle AOC is equal to the measure of angle BOD, and I'm trying to prove that measure of angle 1 is equal to measure of angle 3. So I'm going to mark this up ahead of time. I'm just trying to see where am I starting and where am I going to, which is always important as you build on proofs, because eventually those statements are not going to be given to you. You're going to have to figure those out on your own. So in given, let's start with the first one, that given. And I have the measure of angle AOC, I forgot to label my O there, measure of angle AOC is equal to the measure of angle BOD. And then what I'm trying to prove is the measure of angle 1 is equal to the measure of angle 3. So when I look at that, I notice in comparing, I'm starting with big angles, measure of angle AOC and the measure of angle BOD are both bigger than 1 and 3. And I also notice I have that overlapping piece that I like to talk about. So in starting big and going small, and I have that overlapping piece, a couple things I should realize. I'm going to have a reflexive in there somewhere where a measure of angle 2 is equal to the measure of angle 2. And I'm also going to have to subtract something along the way because I'm starting big and going small. So that kind of helps you talk through the proof before you get started. So if I look at number 2, it says the measure of angle AOC is equal to the measure of angle 1 plus the measure of angle 2. So here's one statement. Again, I have a second statement. The measure of angle BOD is equal to measure of angle 2 and the measure of angle 3. And the reason I can put them in the same statement, even though it's two separate equalities, is because the reason is the same. And again, this one, I have two small angles equal the big angle in both cases. So this is angle addition postulate. Angle addition postulate. Okay. And looking at step number 3, I have the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. I have to go back and see, where did that come from? Well, I have measure of angle 1 and 2 right here, and that's the same as AOC, measure of angle AOC, so I'm going to kind of circle that in red. And when I go back farther in step 1, I see that measure of angle AOC is there. So it's basically saying that the measure of angle C is the same as the measure of angle 1 plus the measure of angle 2. And if I continue, look at the other side, I have the measure of angle 2 plus the measure of angle 3. And again, if I go back, that's the same as the measure of angle BOD. So if I start with statement 1 and use statement 2 and move things around or replace, then I'm actually coming up with statement 3. And when I do that, when I'm moving things around in algebra, I'm substituting. So this is substitution, property of equality. Step number 4, there's my measure of angle 2 equals measure of angle 2, which we knew we were going to have to say if you go back to our diagram. We knew we were going to need that piece. And that's always an easy one. We like that one when it shows up in our proof. That's reflexive, property of equality. And then I'm looking at number 5. It says the measure of angle 1 is equal to the measure of angle 3. That's kind of a tricky one. I have to figure out, where did that come from? It didn't come from the diagram, so it had to come from my steps above. Well, in number 4, it said the measure of angle 2 is equal to measure of angle 2. If I go up further in step number 3, look what happens. If I take out the measure of angle 2 and I take out the measure of angle 2 from either side of that balanced equation, I'm left with the measure of angle 1 and the measure of angle 3, which is what I have right there. So what did I do to get there? I subtracted. So that's subtraction, property of equality.